Oh, so I hope Samuel will be hearing this and will be soon on stage with us. In the meantime, thank you for attending this panel talk. We've been talking a lot about the use of recycled polyester in the sportswear industry here at Performance Days, but also in the industry at wide. And there's been a lot of talk also about the need to switch from bottle rPET to textile rPET. And so I'm very happy to have here today a lineup of companies that are actually recycling textiles into textiles at scale with operational technologies that are not moonshots. So once again, I hope Samuel is coming here soon. In the meantime, I will ask each speaker that is present to introduce themselves and the companies that they work for or head. Tim Cross, will you start?
Sure. Good afternoon. So I specialize in polyester recycling through thermomechanical recycling technology. Basically, you heat it up, melt it, and push it through some filters, and that enables you to recycle back to a pellet, which most yarn spinners can spin a yarn from. So that's what I try and push, is that we need to adopt more of the recycling of polyester because it can and is it relatively easy to recycle. Is that enough? I don't want to take up too much time.
Okay, thank you. Koen, please tell us about PurFi.
So my name is Koen de Ruyck. I'm a textile engineer from Belgium, 35 years in textiles. And 5 years ago, we started with our own machine. And it's a unique machine. There is only one worldwide. And we do fiber-to-fiber recycling, but really only from, let's say, spun yarns and not filament yarns. So that's the difference with the other recyclers. We are not a shredder. And the huge difference is that we have a machine of 170 meters long. So we untwist in a very slow way. It can be polyester, it can be cotton, it can be acrylic, it can be meta-aramide, so that we can do it, let's say, that we can keep the length and the strength of the fibers as plus minus the original waste who's going in.
Thank you. I think I see Samuel. Samuel works for Protex, and this is also a company that has been recycling waste textiles at scale for a number of years, and we're very happy to have you. Sorry about the time problem. No problem. No, maybe you should have.
No, they have to do it there.
Check, check. Okay. Well, thanks for having me.
Yeah.
And apologize for the delay. We were under the impression that it was starting at 4:45. But
I know.
happy to be here. Should I say a couple words about myself and the company?
Please.
Okay, so our company is Protex. Our core scaled technology is text-to-text, which is a textile-to-textile recycled polyester technology. So we're taking 100% polyester textile waste, and we're recycling it into polyester staple fiber, as well as filament through a thermomechanical process. We call it thermomechanical reactor, because this reactor helps to upgrade the quality of the polymer, remove contamination, as well as homogenize the polymer.
Okay, thank you. Well, what I find interesting is that we're talking about high quality recycled goods, which is important. So, first question, as I mentioned, the speakers on this panel have developed different low impact textile to textile recycling methods for polyester and other fibers. I'd like to know, to begin, what made you choose the specific recycling technology and equipment? What are their advantages, and what have you learned from your experience on the ground? So, Tim, you're the newcomer here.
Yeah, I very much am. So I have a background in garment design and manufacturing. So I know nothing about the recycling, or at least 5 years ago, knew nothing about the recycling of textiles. And what I felt was important was to start with something that somebody as simple and stupid as me could understand. And thermomechanical recycling is that you melt the plastic and push it through some extruders. Sam's system is more complicated than mine, but essentially it's the same thing. my view was that if you don't start something, no matter how bad you start, you have at least got going on something, rather than waiting and waiting and waiting and waiting for perfection to come along, because I just don't think it will come along. In 5 years, we have gone from wondering how we recycle polyester to having a polyester recycling machine set up and running in the UK. Now, why was I able to do that? Well, mainly because I'm belligerent and I just insist on getting stuff done and just going for it, rather than holding back and waiting for perfection. So our output pellet isn't as good as Sam's, but it's good enough. And that gives us a point with which we can start and we can move forward.
Okay, thank you. Koen, please tell us more about the PurFi process that you've described as reverse spinning. I like that term.
Yeah, well, I think it's interesting. We have 3 different technologies, and the reason why we started with our rejuvenation, we call it, is because we saw since 40, 50 years, shredding is existing. So you shred everything in very short fibers. So it's used for, what is it, towels or for cleaning things and for insulation. So we thought, let's create a machine who can make longer fibers that we can use as good as the original ones. And that was the whole process that we said, let's do it in very slow steps. So the first thing is we start from, let's say, knitted fabrics or woven fabrics. Can be 100% polyester, can be polycotton. In fact, the system is the same. And let's do it. Let's go from a knitted or a woven fabric to the yarn and do then, we call it reverse spinning. In a slow way, we go back to the fibers. And because we do it that slow, we can keep the length, and then we can do with a similar length. In fact, we can make the original product again. And that's the whole idea at the very start. And that's where we are now at the moment. To make products, we made some denim in 100% recycled content, 50% post-consumer with 50% post-industrial. But we also do combinations with polyesters, with cottons, and with other things. So it's a vision. And in fact, there is a lot of interest, but it seems to be that everybody is waiting for the moment it will be mandatory in Europe before the big push will come.
Okay.
Unfortunately.
Yeah, it's slow. Yeah. Samuel, tell us what's special about your reactor, thermomechanical reactor.
Well, part of our story is really looking at these different types of technologies and recycling processes and assessing them in our own lens in regards to our innovation criteria. And to be relevant and market ready, one of the primary attributes that we're looking for is to be cost competitive. And looking at the landscape of available recycling technologies, we identified thermomechanical as essentially the most cost competitive and robust solution to be able to get to a price point that's on par and similar to existing materials, including recycled polyester from bottles, that is, as well as virgin polyester.
Yeah.
Another attribute and factor that we're considering is in regards to the impact. There are, of course, a number of technologies out there that are being highlighted as, let's say, one of the foremost recycling technologies, such as chemical recycling.
Right.
But I think what isn't being talked enough about is the fact that chemical recycling, when you're doing depolymerization and repolymerization, and you're repolymerizing with virgin petrochemical inputs like MEG, it's frankly just not at the level of carbon emissions and energy consumption and other sustainability attributes compared to a thermomechanical recycling process. So those are the types of factors that really drove us to really push for the next generation of thermomechanical recycling.
And so that next generation, so where you are melting the polyester, so that entails some degradation of fiber quality or not? Or
yeah, so as part of a thermomechanical process, PET is a thermoplastic. So every time you're melting and re-extruding, there's going to be some degradation of the polymer. But what we're able to demonstrate is that when you're doing thermomechanical, the degradation is minimal to the extent that you can reuse this polymer and re-extrude it into a fiber for many life cycles. So in our opinion, thermomechanical really is the first line of defense for textile circularity before we use more, let's say, advanced chemical recycling processes that are a little bit more energy and carbon intensive.
Yeah, and you have to build the factories that are not yet there and things like that. Okay, thanks for that. Now that we've covered the technologies, let's talk about the waste, the feedstock that will be fed into the machines. What type of waste are you recycling? Is it industrial or post-consumer? And where does it come from? Yeah.
So we've got our recycling machine in the UK, and the UK doesn't have the biggest textile manufacturing industry going, but it has got some. So we're looking at the polyester waste that's coming out of that. And as we were hearing in the previous discussion, there is waste from the cutting process, making fabrics. So we use some of that fabric, and that is very easy to recycle and is definitely the preference that we're going to work with.
Right. You know the composition, you know where it comes from.
Exactly. If you do know what you're processing, it's a lot easier to get the right quality of product back out. But we did set up ourselves to be a post-consumer textile recycling process. So we partnered with the Salvation Army and their sorting facility in the UK, which is vast. And they've got a huge problem ahead of them, as do all sorters and aggregators of textile waste, as to what to do with the textiles once you can't export them. So they've partnered with us to try and develop the system that will enable us to work with post-consumer clothing. And we do post-consumer at the moment, but what we're reliant on is clothing that is already 100% polyester and is already recyclable.
Right.
And the challenge there is there's not a huge amount that is already recyclable. So we're trying to work with what we've got.
Yeah, okay. We'll get onto the design question later on. Koen, what type of waste is being recycled at PurFi?
About 4 years ago, we started mostly also with post-industrial waste because that was the easiest way to start. But in fact, for Europe, the biggest problem will be the 7 billion kgs every year who are thrown away. So post-consumer waste is the target and will be the target. And we are lucky the company is based close to Valvan. And we are working together with Valvan maybe to explain Valvan, they automize, let's say, they have fiber sort and trim clean. So first they look what type of textile is it? Is it a cotton? Is it a polycotton? Also the thing that we have seen the presentation before. And then, in fact, the post-consumer waste, they cut in very small parts. Very small, it can be 10 on 10. And then they call it trim clean. They look with cameras, and the cameras are detecting, is it textile or is it textile with, let's say, a zipper or a bottom? And then with air, let's say, air pressure, they push out the parts who are not 100% textile. So I think that will be the future. I saw an update by coincidence last week because they presented it the first time at ITMA in Milan 2 years ago. So it's looking better and better because they are doing combinations of near-infrared together with some AI with cameras. And so step by step, we are moving to a technology who can automate, in fact, the cutting of post-consumer waste. And we did already some first trials. And we see that there is future. Maybe it will take another 1 or 2 years. But it's necessary that it's automated because the price of virgin polyester and virgin cotton is so low that it's not useful to do it in a manual way.
Okay. Samuel, tell us about the feedstock that you are processing.
So unlike Tim Cross, who's doing an absolutely miraculous job doing post-consumer garment recycling, we're currently scaled doing post-industrial or pre-consumer textile waste. So we have 60,000 tons per year of production capacity for 100% pre-consumer textile waste in China. And we're in the process of setting up a facility outside of China that has allocated 1/3 of our capacity for post-consumer garment recycling. As we know, post-industrial is really the lowest hanging fruit because it's more homogeneous, easier to trace,
To collect.
easier to collect as well. But of course, the vast majority of textile waste that's available globally is post-consumer. So one of the issues that at hand with post-consumer garment collection is assessing traceability, as well as RSL compliance, as well as the mixed contamination issues that Tim mentioned as well. And so we're also in the process of working on these technologies to identify, sort out, and to optimize and remove RSLs and auxiliary dyes that may be an issue for our customers.
So what about the tolerance to contamination, and what type of fiber blends can be used in your processes? Can it take in like polycotton, just basically, or not? And what about the presence of elastane? What's the situation there? Does it need to be sorted out systematically, or what?
Yeah, we're really simple. We're 100% polyester,
And that's it.
We have a zero tolerance of anything else, which might sound really bleak, but actually it's not. It's fine. It just means that if we have got anything that isn't polyester, we don't want it going into the system. If it does, we can tolerate it. We just don't want it there in the first place. So we can manage a small amount of something else, but please don't put it in there. For us, that's the best way for us to get something that's economic out at the other end.
Koen, yes, please.
For our technology, in fact, technically, it's not a problem if there is elastane or is there other contamination. But the thing is, what you put in comes out. So if there is contamination of cotton, fibers of cotton will be mixed with polyester, the same with elastane. And elastane will be still a problem because in two ways. With the near-infrared scanner, you don't see it because it's coarse spun, and with near-infrared, you only see the reflection of the outside of the yarn. So if it's coarse spun and the elastane is in the inside, you don't see it.
It can't even be identified.
No. And if it goes through our machine, in fact, you see white spots of elastane, and that's the whole key, I think, to do it step by step. I always compare it with a recycled paper 40 years ago. The first recycled paper was brown and was with a lot of extra specs in it. Yeah. But I think if brands want to go for recycled content and they want to go for post-consumer waste, they have to accept contamination. If they cannot accept it, please don't start with it because it's impossible. And the people who show you GRS certification and say that it's post-consumer waste without any default, I'm sure for 99% that it's fake GRS certificate. So you have to accept. I have some examples on my booth in hall 5C, X3, to show, some contamination is in it. Is it bad? No, but you have to know it before you start it.
All right, okay. Samuel, what about contamination in your process?
Yeah, so similar to other thermomechanical recyclers, we definitely prefer 100% polyester or near 100% polyester. And so those are the types of raw materials that we're going after. That being said, we have a tolerance of up to 5% elastane. Just the output material will be of a lower quality. So in terms of tensile strength and various mechanical properties, you're not going to have the same grade of fiber. So that is currently a limiting factor with our thermomechanical and most thermomechanical recyclers. That being said, as I mentioned previously, we're working on a number of bolt-on technologies to our foundational Generation 1 thermomechanical reactor technology, and that includes bio-based solvents for elastane separation and recovery. And we see that as essential for being able to achieve good quality polyester output and also being able to recover some of those other non-PET fibers and polymers.
Interesting, okay. How far down the line is that development?
So the lab trials are looking very good. When it comes to lab trials, it's always a little bit difficult to say when we'll be able to integrate it on the main line, but we certainly hope in the coming years we'll be able to integrate it in a way that is scalable and cost competitive so that we're able to compete with conventional materials.
And then the point is also to reuse that elastane polymer?
Yeah, of course, we would like to reuse all of the components. We're not planning on reusing it ourselves, but we hope to eventually be able to use the elastane or sell their elastane polymer to a recycling partner that will be able to reuse it.
All right. Let's talk about the design of products then, because Tim has background as a fashion designer, a garment designer. In your experience, how important is it to rethink the design of garments to scale up or accelerate recycling rates? And for all three of you, do you have any advice or recommendations for the product developers that are in our audience today?
Yeah, so anybody who's heard me rant on before, I'm passionate about the idea that you design for recyclability. It's in the EPR legislation that's coming down the line. And the vast majority of clothing brands are completely on board with the idea that you need to design for recyclability. The simple fact is that probably 50 to 70% of all clothing is recyclable already, and a small amount of change will move it from being unrecyclable to recyclable. There will always be some really difficult to recycle product, and that's for the chemical recyclers of the future or the clever designers of today to rethink the way we make clothing. But if you take a simple polyester polo shirt and change the buttons from nylon to polyester, the garment doesn't cost anymore, works just as well, but you've moved it from being unrecyclable to recyclable. So why wouldn't you do that? And you start extending that out through sportswear, through workwear, through uniform, through anything that is monofiber. And you realize that monofiber design will get you most of the way. There are already elastanes that are made out of polyester, so why are we making them out of polyurethane? We just need to transition from a point of unrecyclable clothing to recyclable clothing, and it makes all of our lives an awful lot easier. We'll probably get to, as I say, we'll probably get to about 70% of all clothing can be recycled using existing materials, using slightly moderated design, and you'll have achieved everything we're looking for.
And you don't think it's complicated then?
I don't think it's complicated at all, and nor do the clothing brands. You know, I've started something called the Circular Textiles Foundation, and its whole purpose is to train and advocate for circular design. If you train your designers so that they know what to look for, and it's essentially looking at what the recycler wants. So if you understand what the recycler wants, and you might be a circulose or a Sodra or a Lenzing, you're looking at it from a 95% cotton perspective. All you need to do is manufacture to 95%, and you can then move it to a point where it is circular by design. The same with polyester. For us, it's 100% polyester, and we can recycle it, and we want that feedstock. But transitioning from unrecyclable clothing to recyclable clothing isn't a big problem. It's something we can all do today.
Interesting point. Koen and Samuel, do you have anything to add to the design side of circularity?
Yeah, I think the magic word is eco-design, and it's good that everybody has the good reflection to go to type of eco-design. But what I find important also for brands is that, and then I don't see it only in polyester, but also for cottons and other things, that they, because we are also member of Euratex, the Rehubs, with Concordia PurFi. The first meetings, we sit there with the huge brands, Inditex, Decathlon, H&M. And the first thing they say, yeah, we need, let's say, 36 number English with 50% recycled content. And then I say, yeah, you don't have to ask to jump every day world record. You have to see what's on the market today.
Okay.
And what can we make with the product who is on the market today. Step by step, we will increase the blend, and we will increase the thinner yarns. But you have to start with what is on the market, and not ask for something who is a world record and then say, yeah, you see, the recyclers are not ready. So that's the game.
Point.
You have to do it step by step, and give the chance to increase the quality level and also the percentage of recycled content.
Samuel, do you have anything to add?
Yeah, just echoing what Tim mentioned. I think that as far as possible, let's try to stick to monomaterial products and monomaterial product designs. It makes our jobs much more easy as recyclers, and increases the odds that the garments that brands are manufacturing are going to get recycled at their end of life. So it's really as simple as that. We know that some materials, it frankly just isn't possible, but that's a challenge that many of us innovators need to address, is making more complex and performance material solutions that are able to integrate and be designed in monomaterial constructions.
Okay. Koen mentioned percentages of recycled content, and the key topic of this show is, as we all know, certifications. Which ones count? So I have a question for you about recycled content standards, and was wondering what you have to say about what is missing today in these certification schemes. Also, should a garment with less than 50% recycled content be labeled recycled or not? And should certifications make a distinction between post-industrial and post-consumer waste? You know, the idea is what can make these certifications easier to understand, help consumers understand also where they come from, and make better buying decisions ultimately.
It's a difficult question to answer, because for some people, and probably not this audience here, if we said the product had 50% recycled content, they would see that as a bad thing because it's got recycled materials in it, and that's got to be less good than virgin, right? But if you're looking at it from an audience like this, you're probably going, why only 50%? Surely 100% would be right. And you go, well, okay, we need to educate everybody what that means. And once everyone's on the same page, then that's fine. We can move to 100% recycled materials. But don't let perfection be the enemy of progress. If we've only got 2% recycled material in it, I'd rather it had 2% in it than none at all. We've got such a long way to go, even with Samuel's output capacity, which is far greater than mine. You add all of it together, we are nowhere near being able to replace bottle flake from the market. We're just at the beginning of this journey. So don't expect us to have solved all the problems before you start engaging on this journey.
Yes.
But I think to let's say, you have to make it, let's say, easy for the consumer. So I think it's necessary to have a clear label who's mentioning, okay, it's 10% recycled content. Is it from post-industrial waste or post-consumer waste? So that it's clear. Yeah, because there is a lot of greenwashing, and sometimes I'm very fed up with all this bullshit, because they are all pretending and they are all cheating the consumers with lies or with disinformation that real recycling is, at the end, everything is recyclable for everybody, for every product. And for the real recycler, if I do a walk around sometimes, I say, it's crazy, because I saw even in the last week an advertising that they say, we recycle denim. And what do? We put them in the ground, and it's used as fertilizer for new cotton. And then I think, oh my God.
Yeah.
In Flemish, they say the pants are dropping off. But so a clear label that is understandable for all the consumers is necessary.
Okay. Samuel, your point of view?
Yeah, of course, certifications like GRS are extremely necessary because it authenticates that the material is indeed a recycled material. And I would definitely advocate for, regardless of the recycled content percentage, that it's clearly labeled so that the end consumer can see this. And like Tim mentioned, I think it's a very relevant point that we need to start somewhere. And many brands may not be willing or able to integrate 100% recycled content into the material, into the product from day one. So let's do a phased-in approach.
Okay.
I believe in the 90s, Nike put 5% organic cotton in a range of their products, and they didn't tell anyone. I think that's the type of strategy that a lot of brands need to take today, is it's not necessarily about external branding or marketing. It's about their commitment towards circularity and accelerating textile recycling solutions. And I think that any percentage is a step in the right direction. In terms of labeling, I do think the certification standards could do a better job in recognizing the nuances of different types of recycling processes. Where we're at in the textile and fashion industry is there is some misnomers in terms of the types of categories and the labeling of these categories. For example, as Sophie wrote in a recent article, mechanical recycling is often bundled together with this thermomechanical recycling category, which are vastly different. And so I believe that being able to recognize the type of recycling process, as well as the fact if it's from post-consumer or post-industrial, is an important tool and should be integrated into product labeling standards.
Yeah. Well, I guess it's a learning process. Go ahead.
I can say a last thing about it is I know a Spanish brand, they use recycled content and they are not mentioning it because they say the moment we advertise on a label, it's with recycled content, that the people are looking 20 times in all directions to see any imperfection and then to say, you see, it's recycled, so it will not be good. So they just put it in and they say, don't say anything. And at the end of the year, they say, we have put a blend of, let's say, 10 or 15% in that type of garments. So we have to see which way we have to go.
Yeah, well, I think it's a learning curve. We're educating the industry, and then the industry and the brands, and we'll hopefully get clearer, more clearer and truer messages across. I think consumers are ready to understand, but they need to be told what the situation is all about. Speaking of which, my article in Sports Textiles on thermomechanical recycling, I found out something that I hadn't thought about, is that in the thermomechanical process, since PET bottles are thermomechanically recycled, that category can include polyester coming from bottles and polyester coming from textiles, which are blended together, which is what Unify does. And I was planning on having Unify on the stage today, but they're not even exhibiting, so next time. What's the situation there? Can we, when at Earth Protex, it's 100% textiles. There's no PET bottle PET in your recycled yarns.
Yeah, so when we developed our technology and product, it was always with the goal of being really true to the material and composition and not integrating virgin polyester or bottle flake into our production. I think it would be quite contradictory to offer a textile-to-textile recycled polyester, but have a carrier polymer such as bottle rPET. Yeah. And so that's one of the benefits of our process that we've developed is we're able to get a polymer, an output fiber that is of equivalent quality to that of bottle rPET. But of course, similar to the recycled content conversation, I don't think that good should get in the way of perfection, or the other way around, rather.
Yeah, is it a transition?
That it needs to transition, and if some recyclers need to add some bottle flake into their recycled polyester, so be it. Hopefully it's with the end goal of becoming eventually 100% textile to textile.
Right.
But
we won't get there.
It won't get there overnight. That's right.
Okay, interesting. So that covers pretty much what I wanted to ask you. Let's hand everything over to Charles and the audience.
More importantly, before I take questions from the audience, can we show our appreciation to the guys on stage? Now, I personally have some questions that I want to ask them. I'm going to embarrass Tim because I know he's kept very quiet. He currently has his work on show at the Design Museum in London. He doesn't talk about it enough.
That's right.
When recycled textiles are elevated to design leadership, full credit. But I would much rather have a question from the audience than have Charles rabbiting on. So this is your opportunity. We've got a group of people who are more aware of the current direction, how far we've got already, and the potential we can go into. Does someone want to kick it off? He says, looking around. And start to worry if I know your name, Esther. Oh, we have questions over here. You're saved, Esther. Oh, Simon's in the audience as well, and Stefan. And Nat.
We welcome you to stay to our happy hour tonight, sponsored by Ruyck, starting at 6 p.m. in Hall 4 at the Expert Talks area, with a live DJ set, free drinks and snacks. Our shuttle service from entrance north to entrance west is available until 9:30 p.m. tonight.
Okay.
Go ahead.
My question isn't if you want to go to happy hour. It's a question for both Samuel and Tim. And can you talk about whether you have any decolorization in your process? So if you're going to take post-consumer garments, how you deal with color?
We don't at the moment. We separate according to color. And we will obviously, if we've got white, we will keep the white separate. And if we've got colored, we will grade that accordingly. I think that decolorization is going to be a very important tool to have in the future. And I'm certainly not against it. I think it's a good idea. Where we're at the moment is that we can always dye to black. And we are a long way off getting all the black that we need. So we've got that opportunity of dyeing to black. And it's very easy for us in our process to just introduce a master batch of black into the process, and you end up with a black yarn. Most of the time, to be honest, we are selling the pellet to yarn spinners, and it's up to them to choose what they wish to do with it. But decolorization, yeah, definitely part of the future of thermomechanical.
I think it's another transition phase, because Unify sorts whites and colors and only offers two colors of yarns.
Yeah, so in terms of our commercial production as well, we're sorting by colors. So we're sorting whites and light colors as well as dark colors. Our dark and medium and dark rather mixed color waste is going into light and dark black fiber outputs. And we're, as Tim mentioned, adding dope dye black master batch or carbon black. And that it enables us to have a homogeneous color output. That being said, for large customer programs, we're actually able to collect, aggregate, and sort by color, and then add dope dye master batch in those colorways to have a recycled color story, and that also enables us to use less master batch when we're recycling by color. So that's where we're at commercially. We are also developing in the lab decolorization tech, and we've had really good progress on that. So that's one of the areas that we hope to integrate in commercial production in the future as a bolt-on technology.
And we've got a follow-on on much the same subject, Sophie.
Yeah, I had exactly the same question. So maybe I can bolt on. Are you guys doing much research or need to build up the knowledge about dye stuffs and the different types of dye stuffs that are easier to decolor the polymers? For example, do you know some answers now, or is that a piece of work that needs to be done by you or someone else? So you could advise, or someone can advise, again, designing for recycling.
Yeah, there is, and there's some clever work going on at Leeds. And I know that there's good ideas in there. The trouble is, if you use some of the dyeing technologies that are easy to remove the dye from, you then need to know where those garments are once you've made them. Yeah. Because otherwise, if you need to do a particular process to remove that dye, and you're just going to put that same process through absolutely everything just in case some of it has got that, that's not going to work. So closed loop systems where you've got uniform, that might work. And a global plan where everything is dyed in exactly the same way so that we could all just remove it in exactly the same way. well, that's never going to happen either. So I think it's useful, but it's not necessarily an easy answer.
Yeah, and in terms of our work right now for decolorization tech, it's still in the lab, so we still have a lot to do, work to do rather, for decolorization of vast quantities of materials, different types of dyeing methods and dyes. So there's a lot of work ahead, and a lot of that work will be proven out once we get to bench and pilot scale. Hope that answers your question.
Well, dyes are made to be not removed, right? Koen, can you contribute something to the color story there?
For us, it's easy. The color is going in, is coming out, because we are not using chemicals. So we're also working in color groups. So let's say the whites, the light colors, the navies, the blacks, and then the mixture of everything. But the mixture of everything, then you have to over-dye in black.
Yeah.
But because we are not using chemicals, for us, color in is color out. And if it's dope dyed, what we are doing, like for meta-aramides for the firefighters and for the army, it's easy because the color is staying exactly the same at the start or at the end. So we did some tests with the delta E, and we saw that you're less than 0.3, so visual, you will never see the difference.
Yeah, so once again, it's about a closed loop. Okay, thank you.
Hi, question here. I think you mentioned all three of you are thermomechanical recyclers.
And one
is not. Right?
mechanical.
And filament fibers, right? Filament fibers not stable. Just curious, so what's the most comfortable fine denier or fine filament that you're currently spinning? That's question number one. I have another question.
Okay.
Give them both questions.
Okay, both questions. All right. Yeah. So another question is regarding one of you mentioned brands and recyclers were highly dependent on the GRS certification by Textile Exchange. But we're also knowing that there are some loopholes, and it's in some ways, if you're a recycler and brand, if you're a recycler especially, you know it's easily manipulated. There's a lot of gray area in terms of your feedstock, traceability and transparency. How do you see about this, and how do we overcome that?
So just to clarify that, we've got one on certification, clarity of certification, and one on the size of the denier of the yarn coming out.
Staple filament, right?
I just want to respond concerning GRS certification. So GRS certification, it's a paper transaction. Eh? So you give one paper that you say, I have a delivery, and you give it to someone else. For me, it's not the brand who can say, yes, I have the certification, they open their umbrella and everything is covered. For me, they are responsible for what they are buying. So they have to know for sure that it's not greenwashing and that's not just a paper transaction. So for me, that's necessary, because otherwise it makes no sense to have a GRS certification if it's only a paper. And it will not help to solve the 7 billion kgs of waste in textiles.
Yeah, in terms of your first question, what are the type of fiber deniers possible? So of course, staple fiber would be the lower hanging fruit in terms of feasibility of production for lower quality recycled polymers. Our core workhouse fiber specification for staple fiber is 1.5 denier, 38 millimeter. We can, with higher quality inputs, do 1.2 denier. We just started, as of last year, starting to do POY, DTY filaments. Until just recently, we were doing two DPF, so 2 deniers per filament, but now we're getting much closer and starting to commercialize products that are closer to 1 DPF. So constantly challenge, and right now it's more about continuous improvements and optimization of the technology to get to better polymer output as well as finer deniers, because we know that a lot of the fashion space in terms of against the skin applications needs those finer deniers. In terms of the certification, just like everyone else, we're GRS certified. We have a special designation that our certifying body has given us, recognizing our process. But there seems to be some changes in the works from Textile Exchange certification standpoint. So I believe that the path forward to really be able to authenticate different types of recycled polyester and the inputs that are going into those materials needs to be closer to what is now currently the content claim standard, where there is some, let's say, customization and nuance that's able to be integrated into the certification to allow for recyclers to explain more about their type of recycling process and the material that is going into the recycling process. I think there's also a lot of work that needs to be done around documentation. For example, for every transaction certificate, why aren't we taking pictures of the feedstock, uploading that to a database? There should be more documentation of the chain of custody across the supply chain, and that way it will be much more difficult to cheat the system and to have certified recycled products that are indeed actually not at all recycled.
Yeah. We could do better on that stage. Yeah. Tim, anything to say?
No, I think they've covered it. I mean, everything you said on GRS, I completely echo. Yeah.
Sophie?
Thank you for all the explanations up to now. We talked about the feedstock in monomaterial that would be ideal, and you were also talking about blends. But what about fabrics that have coatings? And can that be recycled? And if so, is there a preferred coating that we should use forward in order to get that fabric recycled?
Yeah, there is. So I don't want to touch anything that's got PFAs in it, and I can't touch anything that's got PU in it. So coatings for me are a big problem and a big challenge. But thankfully, the industry is full of innovators, and there are loads of people coming out there with monomaterial solutions. Protex have got a polyester membrane that's on a polyester outer. I've got a polyester garment that I can fully recycle. So great, let's focus on that monomaterial. Charles, you and I were talking about polyprop inner and outer material. I saw one here today that's got a polyprop lining that achieves that level of breathability and permeability that we're looking for. So there are solutions out there. We just need to move away. Everybody's rushed away from PFAs to PU, and we're breathing a huge sigh of relief that they're now on the good step. Now we're just pushing them back onto the naughty step again.
The less bad step, not the good step yet.
Yeah, exactly. So, but if you look at some of the Nick wax, for example, or any of the other eco membranes that are out there that we can use,
is polyester.
Yeah, we can recycle all of those, and so I don't have a challenge with any of those particular products. So I don't have a challenge if I need to know that they're there. Or could be there, and that makes it easier in the recycling process.
So if I understood correctly, PET coatings are okay, so we can work with that. But what about other type of coatings, so PVB, for example, or PVC, or PU you were saying? No.
PVC is evil. Just take it, do not go near.
I can add a little bit onto that question. I think a lot of these technologies that are being developed, including by ourselves, for elastane dissolution. Of course, polyurethane is a type of elastane is a type of polyurethane, so they can theoretically be used for coatings. So there are technologies in the works that are addressing these coatings, and as I mentioned before, there's a lot of complex materials that it's hard to get away from these complex multi-polymer constructions, and you really need to get the performance and the end product performance that designers are looking for. I do think that there is a lot of amazing work in monomaterials and as well as PET coatings. I don't know if it's quite there in terms of the performance relative to PU or PVC. On the part of PVC, PVC is actually recyclable using thermomechanical type processes. So there are some recyclers out there that are addressing this issue for PVC recycling. And I won't mention or touch on the point around the sustainability aspects of PVC.
Could we just chuck in an additional comment? I sit on the judging panel of the Fabric Forum, and what's really been positive, whereas we know Sympatex and the other polyester membranes are a great move forward, the glue has not been a polyester glue because of a low melt temperature. We are now seeing adapted polyester glues coming in. So in 5 years' time, I hope this is going to be a redundant question. But I have yet another question from the audience.
Thanks, guys. So end-of-life textiles is an inherently dirty business. You know, it gets soiled on the way in. What strategies do you have for dealing with that kind of soiling for thermomechanical processes? Because you can't really launder because it adds moisture, which is going to screw up your process, right?
Sorry, that is clearly directed at me. Again, I think there will be a laundry process. I think there will be a cleaning process to deal with a lot of the dirt, the organics that are in there. This is obviously in post-consumer. It's not such a problem in post-industrial textile waste, but post-consumer, by its very nature, contains everything that life has thrown at it. And by the time you put it in a recycling bin, the very word bin gives you all you need to know. It's where you throw stuff away. And it's got lots of contaminants in it that weren't there in the design process. So how do we cope with all of that? And looking at systems that clean that up, yeah, that's going to be a fundamental part of what we're going through. And we're doing lots of work with clever people trying to figure that out as we work our way through it. So, yeah. Does that answer your question?
Thanks, Tim.
Thanks, Nate.
For the people who don't know, this is Leeds Research, who, coming back to a much earlier thing on the colour, decolorization, they're not in the decolorization team. But there's some really interesting stuff happening in the University of Leeds. But Sophie, if I can throw a question back to you, because you had a brilliant panel at the last show when the theme was colorization. So progressing on from that, we saw the rise of biopolymer dyes, algae dyes. Can I ask the three people on the panel themselves, we know synthetic dyeing, we know natural dyeing. How close are we to understanding biosynthetic dyeing? So that's when we take color from another source, a natural source. Has it yet been included in your conversations?
Are you talking about the biotech, the microbe-made colors and
I'm talking algae dyeing, things like
dyeing,
that.
all those.
So is it yet on your perspective? Have you yet had to deal with it?
Yeah.
It's a new version of coloring. Essentially, natural colors are good, but we can't get the durability. Synthetic dyeing is superb, but it's got naughty stuff in. There is a third way, and that was everything the last show was about on colorization, where we were using algae to be the stimulant for this dye. So I just wanted to know whether you three on the panel were now starting to see what we're calling biopolymer dyeing.
I don't know if there's enough of that on the market today to reach your stage, unless it were a workwear or a uniform company that wanted algae dyes and then a closed loop system and tralala, tralala, and all that would be perfect. But I'm wondering how different it would be, because
yeah, I want to know, is it on your spectrum yet? Have you looked at it? Do you know if you can do it?
Yeah, so we are providing some material for a major brand. Not going to name names, but it's a German brand, and they wanted us to work with an algae dyeing partner, and so we're in the process of doing sampling with an algae dyeing partner, and we're very much looking forward to seeing the results. As I think this is potentially the future of dyeing. We'd love to see this at scale, cost competitive, see the impact at scale. I think not just for dyeing, but all kinds of biomaterials in the biomaterial space, biofuels. It really is the future, and there's so much potential here. So we're going to support it in every way we can.
Right. Yeah, algae is being used also as like an auxiliary in dyeing, so not necessarily delivering color, but a thickener or something like that. Have you bumped into any biotech dyes recently in your...
Not really, because in fact, dye stuff is not really an item for us, because we are not using anything or decoloring anything. So for us, it's less an item on today.
We do look at it. We try and understand it as much as we possibly can, but then we try and look at every different dyeing technique that comes through the door, and we want to understand why we can't recycle something, particularly in post-consumer where you've got so much variation. We're constantly looking at, well, what was the barrier for it to be recycled? Was it the dyeing? Was it the coating? What was going on there that caused us a problem? It's complex.
First of all, I want to say thank you so much for the work you're doing, all three of you, amazing. And also to ask, from a holistic point of view, obviously this is much better. Have you ever done any LCA analysis to be able to put numbers to the process and say, where it's got highlights and lowlights?
I think it's necessary to have an LCA calculation, but the thing is, if you can do an LCA calculation in Holland, you can do one in Scandinavia and one in Italy, and you have different results. So also there, Europe is looking to harmonize one type of system, in fact, to have a result that you can compare apples with apples, and not that for the same product that you have three different results. But it's necessary to have clear figures to show what the advantages of using recycled content. Otherwise, make no sense.
Yeah, we do have a third-party published LCA that we did through ITS, and this is based off of our scaled manufacturing process. And we're really happy with the results. It's substantially lower than, of course, virgin polyester, but as well chemical recycled polyester and bottle thermomechanical recycled polyester. So there's a really big advantage to using textile waste as a feedstock, as well as going down the thermomechanical approach. And to make it easier and to understand this raw data, we've developed some tools, including an impact calculator on our website, so you can easily input your product, the type of composition, the product specifications, and measure and quantify the impact reduction for that specific material based off of our LCA data and other third-party LCA data. So, of course, these are amazing tools for brands and stakeholders and even consumers to really visualize the impact. But then again, LCAs aren't perfect tools, and they do need a lot of standardization.
Yeah, exactly that. No two LCAs are the same. We've carried out ours by UAL and RAP, verified the work that we did on that, and it was all very good. It's something like 11% of the carbon cost of virgin, which I thought was brilliant, and that's great. They are all infinitely better than virgin, and that's the bit that you need to focus on. We've similarly got a tool that you can plug in the numbers and see what the carbon savings would be by following one route over another. Obviously, there's no water involved in our process.
If I could just chip in for the guys who don't know, LCAs, we think of this exact science. LCA will measure the waste, the energy, and the water, and up to another 20 factors. You can do an LCA on just 5 factors, or you can do one with 25 factors. Because there's not hard to, although it is science-based, because we're allowed a variation of what we're feeding in, this is why we're getting different answers. So I can only echo what you're saying about base it on science, but the scientific method at the moment is not secure enough. But that's a different problem for a different show. Yeah, I'm looking around for questions, and we have a question. Another Adidas person.
So have the social LCA. To have a combination, the social
Thank you. Thank you very much for the discussion so far. Thank you. I had a question for Sam and Earth Protex. You mentioned you were scaling and that you were opening a new facility beyond your China facility. Are you able to talk any more about that?
Yeah, so I can't disclose the exact location. Perhaps after the talk, if you visit us at the booth, we can share more information about our international expansion plans. But just the high-level details, it's outside of China. The design capacity is 30,000 metric tons between 2 production lines, so 15,000 metric tons for raw white and light colors, and then the other one for dope dye black. And we're also positioning ourselves to rapidly expand production capacity from there. We are very much looking forward to integrating different types of materials, including post-consumer, as I previously mentioned. But also on-site, we will have a technical center, which will enable us to do quality control, not just physical parameters, but chemical compliance and analytics on site, which we see as very important, as this is a hot topic for many brands in terms of RSL compliance, but also for product development and piloting of these next generation technologies. So we will have a mini pilot line where we're actually doing rapid iteration optimization of our production process. So that's a little bit of a teaser. If you want to learn more about the facility, I'd be happy to talk to you after the show.
We're going to wrap this up, Sophie. Samuel, Adidas. You might have heard of them. But Sophie,
thank you, Charles.
Over to you. Can I ask everyone, just before Sophie wraps up, can we yet again show our appreciation for the panel for taking questions from the audience? Sophie, what else would you like to add to the conversation?
Well, I'm happy to, and this is what I try to do on stage here at Performance Days and at Sports Textiles, is to bring clarity to all these very confusing or murky topics. And when I spoke with Samuel last year, he's like, everyone treats thermomechanical as being the same as mechanical, and you should really take a second look at it because it's not the same. And so that's my job, is digging in deeper. But I do believe that the certifications, the topic of this session, we definitely have to find a better solution because they're just meaningless today, or near meaningless, and that's not helping the business go forward.
For the people who didn't catch the chat just before lunch on certifications, all of these sessions are uploaded onto performancedays.com within about a fortnight. Go back and study it. We had other people with really good observations. One of the biggest takeaways was the need to simplify, was the comment they made. But I'm going to ask you guys to disappear off stage. Otherwise, Alexa's going to jump on me because we're running late for the Petracuchas. So we're going to have a 5-minute swap around. If you don't know what a Petracucha is, we've taken the best out of the innovation zone, and they get 20 slides in which to paint the dream of the area that they're working in. Every slide turns on 20 seconds. So they have exactly 6 minutes and 40 seconds. They will be on stage within 5 minutes.
Okay.
So
thank you so much.
Stay around, pay attention, and I think you will enjoy the Petracuchas.
All right, one last word. Thank you so much for being on stage with me today.
Thank you, Sophie.
Thank you.